Ya está. Uno. Y el tuyo también. Ya está el micrófono.
Bueno.
No.
Ya
está el micrófono. Ya están. Bueno, entonces tú dices ya. Ya. Good afternoon, everyone, and welcome. Thank you for joining us today for the seminar Natural and Anthropic Hazard in Mexico City, What to Expect in the Future, organized by the UNAM UK Center for Mexican Studies in collaboration with King College London. My name is Antonio del Rio, director of the Center for Mexican Studies, UNAM UK, and I have the pleasure of moderating today this session. It is now my honor to introduce our speaker, Dr. Carlos Miguel Valdés González, a full professor at the Institute of Geophysics in National Autonomous University of Mexico, UNAM. He holds a PhD in geophysics from University of Wisconsin and Madison, and has served twice
The topic today is natural anthropic hazards in Mexico City. What to expect in the future? Just to give us some idea of what are we want to talk, according to Mexican mythology, which supposedly ordered the Aztecs present. If they had waited a little more and let the eagle fly towards the dry land, things would be much better. But that wasn't the case. Mexico City is one of the largest cities in the world. The urban area contains about 21 million people, 6.7 million houses, and Mexico City, as you can see in the map outlined in the blue, that's Mexico City, and the whole urban area it's in the top. It's a city that keeps just growing faster every time. And what we would like to show you here in these maps is in blue, it was the Great Lake of Texcoco that covered the whole, a very large part of the city, and how this progression of the dwellings were being located and pushing essentially away the lake. And in the final picture in 2016, we see that all the area that used to belong to the Lake of Texcoco is being occupied for urbanization. And that's one of the main problems. What we would like to talk here about is the problems with the water. What is the meaning of the water here? The pollution, the volcanoes, earthquakes, sinking, drainage, transport, airports, chemical and technological problems, and socio-organizational. Just a few of them, because the list could be just on and on and on. So we can say that historically Mexico was founded in a very nice place, and the lake that we now is now below the city, but it's essentially hidden in this in the subsoil, saturating all this land. And it is important to say that there wasn't only one lake. There were a few more lakes that were above. And when the rainy seasons will come and when they have large storms, all this water will be draining essentially to the bottom, to Texcoco, to the Lake of Texcoco. which is the part where Mexico City is the center of Mexico City is located. So essentially, it's a basin with different levels, and this continues to move there. Just to mention a few things, in the general law of civil protection, there are the identification of these hydrometeorological and geological problems. We could talk about extreme rainfall, the storm floods. We could talk about droughts, earthquakes, volcanic eruptions, slope instability, subsidence, and cracks. Although they are in the law, that doesn't mean that they are solved. And that doesn't also mean that there is enough money to be studying and finding solutions for all these problems. But let's start with the first one, with the water. And as we say, Mexico still has 45 rivers that now flow in pipes. They are under the streets like Ghost of a City Paradise that changes its habits. But the damage, we are told, is reversible. And that's one of the important questions, if we are ready to have rivers in this city again, because that's something that we can attain, but it requires a lot of changes in our habits and a lot of what we do with the pollution, with the water and things like that. So you could see clearly that this is a closed basin. And we will talk about a little more about volcanoes, because the volcanoes to the south part, this used to be a valley. It will be draining towards the south. But the growth of the volcanoes, we'll talk a little more about that, close this valley, and then it turned to be a basin. That is the reason why it will form a lake. These are some of the images. We could see the one in the left, top left. There are these pieces of floating land, which were called chinampas, that were used to cultivate and to build houses in the past. And we see still, or we saw still some of the channels that will be moving in the city. We could see even a vapor boat in the left below. And now, what used to be a river, a flowing river, we now have rivers of cars. That's part of what we need to change in order to recover this particular situation. You could see some of the constructions that were made in order to pipe these rivers and put them below the surface and make on top of that a highway, so we could just pass through these rivers without noticing them. One of the main problems is the water. As we talk about 21 million people, there is a lot of requirement of the water, and this is a kind of a complicated slide, but it just shows a lot of the places where the water is obtained and is pumped towards Mexico City. You could see at the very top of the slide, there is a Tuxpan. That is a location that is more than 130 kilometers away from the city. And also there is a difference in level. We have to pump this water 1 kilometer top. You can imagine if we could take
one of these bottles of water of 20 liters, they weigh about 20 kilos. If we have to climb 5 stairs or floors, it will be a lot of work to be done. Now we should consider all this water moving towards that. This is a little more clear. We see there are 132 kilometers in a straight line, but the water keeps moving from different dams to different dams until it moves finally to Mexico City. That takes about 40% of the water in Mexico City. This is one of the largest dams, the Valle de Bravo. And this is a picture, this is a real picture from last year where there was a severe drought. You could see the limits, the edge of the lake is really depleted. And by comparison now, we have had a very strong rainy season that have pushed again to 95.5% of the capacity of this dam. This will be able to sustain the water for Mexico City for 3 years. But because things keep just changing and because the climate change is here, we are going to see probably more droughts. And these droughts are going to be every time more severe. So one problem is when we have 95.5, no one cares about doing things in order to provide the water for the future. You can see these gigantic pipes. Look at the size of the truck. They have about 2.3 meters in diameter used to be one of these lines, and then another new line is being built, and you could see how they take the water, they keep just moving it to different stages until they complete 1 kilometer. So it's a lot of energy used to be moving that water. But not all that water comes from that. The 41% shown in the left corresponds to all this water that is coming from other states, the state of Mexico and the state of Michoacan. And the rest of the water is coming from different situations or different places. There are about 470 deep wells. Most of them are located in the south part, where they have the numbers in each one of these little squares represent millions of liters that are being used per day, for a total of 2,295 million liters per day. This, if we just change that, it will be a river where we could just have a boat. It could be a river of 3 meters of height by 10 meters across. So it's a river of water that is being produced. But also the other problem is that whatever it goes in has to go out. And the drainage system, we will talk also more later, it goes to the north and it goes by gravity. And we are going to see another problem in Mexico City that is a severe problem, which is the sinking of the city, because it has a very soft soil. And then what used to go very easily out from Mexico City just by gravity, now in some cases has to be pumped to move it away. So that is a real problem. In this particular year, we have had the heaviest rain in the last 43 years that's been recorded in this year. You could see all these places, and it's ironic because we have all this water in this part, but the structure in the left of this small highway, it's one of these rivers that is piped. And again, we can see the situation and some of the amounts that it rained, 662 millimeters of rainfall that exceeded the historical of 530 millimeters. So we had 60 centimeters of water covering all the city, and of course it accumulates in the deepest part. And in June, we have that number, 485 million cubic meters of water. And in July, also, we have a lot of water. And all that water goes away because it goes to the, we don't have places to store it. And again, we forget about that because when it's raining so much, we don't care what happens with the water. And eventually we will hit another drought and it will be a real problem. Other situation that is complicated is air pollution, because it's a closed basin, which is at 2,200 meters of elevation. It is close to the east, to the south, and to the west by tall mountains, and only to the north, but the winds prevail from the east to the west or from the west to the east, depending on the time of the year. So whatever accumulates within this basin that is surrounded by these tall mountains, as you could see in this image, it stays because the air doesn't move it. A lot of energy is consumed. These are the percentages used in transportation, in industry and services, and in residential use. And that has the problem of a lot of pollution. And we complain that we have a cold weather now, nothing compared to these places, much colder right now here. The pollution stays closer to the surface. So that brings a lot of problems, and it will not move away until the next rainy season. And the rainy season in Mexico starts in May. So we have real problems. February and March are probably, and April, the worst months where we have this pollution that is affecting a lot of people. This is a complicated table, just to mention that there is an index called IMECA, which is a Metropolitan Air Quality Index, which is a measurement that transforms the pollutant concentrations into a single number to inform the public about the air quality. It will take into account the nitrogen dioxide, carbon monoxide, smaller particles of 10 micrometers and suspended particles, and sulfur dioxide. And the combination of these will give us different levels. And when we get to more than 150 in this index, then the city take some measurements, and they are called contingencies. We could see through the years that they've been changing. For instance, last year we have 12 of these contingencies, almost one per month. If we divide it into each one of these months, because there was very little rain, it didn't wash away. And this is one of the measurements that the government does. They decide, depending on the ending of the license plates of the cars, which ones will not circulate at all that day. But we are not fixing the problem. We are just giving a small pill to deal with the problem in that day, expecting that the pollution will go down to the next day. But the solution has to go much further than that. The better use of the cars, sharing the cars, using other type of transportation, massive transportation, and all these things. So, and of course, the government, we have this information. You could see in different parts, again, in the city, which is highlighted in black, if it's acceptable in yellow, for instance, bad in brown color, and in this case, there is no a very bad one, but you could see how it changes. It doesn't stay in a particular place. A lot of these pollutants come from the north and move to the south and get trapped into the city. We move to another of the problems, which has to do with the volcanoes. In this slide, what we see, well, this was a little bit of animation, but what we are seeing here, they're responsible for the earthquakes and for the volcanoes is the moving of these plates. We see at the bottom the Cocos plate that moves towards the Mexico and enters into a subduction zone, and it produces large earthquakes there, but it also produces that when the slab is going down and when it reaches about 100 kilometers of depth, it will start melting the rock, transforming it into magma, which starts just migrating to the north. So we see this line in the middle of the country that is filled with volcanoes. So these symbols are the orange and blue ones are large earthquakes, but the other ones are volcanic fields. And that's the reason why we have volcanoes. They should be more located to the coast, but in this Mexico case, they go in a straight line. Within Mexico City, within the political area of Mexico City, there are 140 volcanoes that have grown in the last 24,000 years. If you make an average of these numbers, you will have that about every 300 years, you will be able to have a volcano. That doesn't work that way, but it is still a volcanic field called Chichinautzin that could be active. All these dots, you could see that they represent volcanoes, and the reddish ellipsoid that you see in the middle, that is a lava flow of the most recent volcano. We will see a few slides ahead, called the Xitle. That's where the university, the National University, is located, and that area is called the Pedregal, which means the rocky area of the city. And we will see this image was painted because there was this eruption 1,600 years ago of the Xitle, and there was a civilization called the Cuicuilcas that had a sacred area built, a pyramid, a circular sacred pyramid, and they have to migrate because of the eruption. They tried to build a wall, there are remnants of that wall, to move or to try to push the lava away from the constructions, but it wasn't possible, and they have to move to different places. And we see this other image. This is the pyramid Cuicuilco, which means the place of the songs and the prayers, that was built between 800 BC and 250 AD. And this site, as we said, was covered by this lava flow from the Xitle. You could see these remnants, and you could see these modern constructions just next to the pyramid, and also the university is essentially across one of the main highways. This is another view where you could see the highway to the left, and you could see part of the city, and you could see a lot of other volcanoes, those mountains with a flat top on top. There are all these volcanoes, and this is the center. This is a recent picture, so the place stays there, It wasn't all covered by they excavated part of the pyramid to see the bottom part. This is an image. All the yellow part represents this volcanic field, which is called the Chichinautzin field city on top. And the question is, what will happen if we were to have an eruption of the same volcano? It will not happen because these volcanoes are called monogenetic. That means that they have only one eruption, one birth, and that they die. They are a smaller volcano, not really that smaller, because they produce 1 million cubic meters of lava, which is quite a lot. As you could see, all the extent that the lava just went all the way towards the north of the city. But if that was the case, if this eruption will occur today, by using the National Atlas, we could see that there will be 7,100 people affected, 228 dwellings or houses. There are 54 health institutions. There are 702 schools that are there. And that is just to say that this volcanic field is somehow still, is possible, is probable that it could have a new volcano, and that's what part of what the university does. It has some equipment just trying to monitor whatever is happening in this south part. Something that I forgot to mention is that you are looking at the limit of the inhabited part of the city, but this is actually half of that map of the city. To the south, where the mountains are, where these volcanoes are, there's very few people there. And one of the problems that these volcanoes will have is the production of the ash. And the ash, this is a graphic that tells how to deal with the ash, but I think this figure is more representative. What you see in the red circle, the large red circle represents the diameter of a human hair. And if you look to the left and to the bottom, there is a little speck in red. Look at the size of that. That is way too small, and it could just go through the blood circulation. And if it gets into the blood current, it could go to any organ of the body. There have been cases where they have found particles of ash in some of the human organs, and you could see we call it the fabric of the ash, which is essentially a glass, has these shards. They are very sharp, and they will destroy or they will cause damage to tissues that are way too delicate. So that is one of the main problems that we could face. And of course, the use of now that we pass all whatever the COVID had to do, but these masks were once the best protection for the ash. And these ellipsoids, they are all coming in the part where they are originating. That corresponds to a very large volcano called Popocatépetl, which is located about 60 kilometers south east of the city, and the different color ellipses represent ash movement in one of these eruptions. This volcano has been active since 21st of December 1994. It is going to be 31 years of activity, and it continues to spread. And the name of this mountain, this is a tall volcano. This is a polygenetic volcano, a volcano that has many eruptive episodes. It is 5,400 meters high, and it produces the name Popocatépetl in Nahuatl, means mountain that smokes, and that's one of the reasons. And you could see those little planes represents airports located in the radius or in the zones that have been affected. So that's one of the problems. These are a few things that we need to do in order to deal with the ash. But some of the things is, of course, the ash, because you saw those shards. If you start just trying to clean your car with a dry cloth, you are going to scratch the windshield or the paint in the car. And also if they go into the braking system or in the filters, because they have this texture, it will damage the systems quite a lot. If it accumulates on top of the some what we call the fragile roofs, it mixed with water, it could easily collapse them. These are some of these moving markets that are common in Mexico City. And another problem, which is a real problem, is that the ash is very fine and it falls on top of the city, and then people use water to clean it, or if it's in the rainy season, the rain takes the ash into the drainage, and when it dries, it becomes like a cement. So what we are going to have is arteriosclerosis of the drainage system, and that's a problem, because if we clog the system, you go and wash your hands, you go and take a shower, and the water just will not go. And that, in order to clear that, is going to be a problem. That's a picture in the side of Puebla, where you could see the visibility becomes very low. And also because they are solid particles, when they are like in the past picture, you cannot use your cellular phone. It will not transmit because the waves are too small. It will not pass through them. And you could imagine what is the impact in the airplanes. It's very abrasive. So if there is an encounter of the ash with a plane, it will damage the skin, the aluminum skin of the plane, or if it gets into the engines, it's not going to be very, very good for the engines. Look at the amount of ash that falls on top of these planes. And we end this part of the volcanoes just by looking this image. They look a lot closer, but it's just because it was a very, very nice day. And you could see when there is raining, there is no pollution, but there's no pollution, but we could see the Popocatépetl emitting. So now if we move into the earthquakes, this is a map of the seismic activity. Mexico is a very, very seismic active country. In the year 2024, we had 33,396 earthquakes per year, about 91 per day. But because we are concentrated in Mexico City, if we do an analysis of the intensity is the severity of the ground shaking. And when we locate Mexico City, where the red arrow is, it's located in an area where important damages had occurred, which is there are these intensities between 7 and 8. This is this is not the Richter scale. This is the Mercalli modified scale. And again, this is a picture of Mexico City. You could see some part of the contour of the city in the north part, the one that is more inhabited. And it's very interesting because when you look at the seismic zonation, it has to do exactly with what was the Lake of Texcoco. If you look at the edge of the lake and you look at the yellow contour, they match. So we have in the gray area, it's considered hard rock. The movement of the earthquake is not that severe, and the earthquake doesn't feel that long. Then the yellow, which was the shore of the lake, start becoming a soft sediment. When we step into a lake, our feet just touch the sand, and then it just pushes and moves. And then the colors green, light green, darker green, brown, and red, those are the zones of amplification. And the amplification is very important. When you look at the blue lines close to where the scales are located, that says periférico, that's where the National University is located. When we compare, you could look at the airport located in the red part, and the difference of motion between the university that is hard rock and the airport is, in the airport, it moves 30 times stronger. So it's a completely different type of motion, and they feel like the earthquake is forever. And in the place of Mexico City, in the university, is very different. And this is because of the soft part that has to do with the lake, the Texcoco, the remnants of the lake. These are the municipalities of Mexico City, and just to indicate, the ones that have a white color represents those that have a seismic zone 3, which is the amplification. Seismic zone 1 is hard rock, seismic zone 2 is the edge, and then the 3 is divided in 3A, 3B, 3C, and 3D. just because it was too large. And this is just to show in the left part, there is the letter CU, which represent Ciudad Universitaria, and again, that the comparison is the amplification of the 30 times that they moved. So you need to know in which zone you are, and you need to know where or when the buildings were constructed, what happened to them, and this responds to large earthquakes that come from the Pacific. But within Mexico City, again, you could see the shape of Mexico City, and you could see all this seismicity from 2010 and May 2023. And there are a lot of faults that cross the city. And recently, there have been a lot of earthquakes. These are 115 earthquakes reported since the beginning of last year until this last month. And again, you could see the city, the populated part of the city extends about over here. This part is empty, and this part is very densely populated. So those earthquakes, although they are small in magnitude, they feel, because they are so close, they feel really strong, and they have been causing a lot of problems. We have a powerful tool, which is an alarm system. I'm going to just jump across that, so we will go and see the damages. These are damages from an earthquake that was located 120 kilometers away from Mexico City. It was a magnitude 7.1, and you could see that have to do with the type of constructions, very heavy. You could see these balconies are very heavy, and they are totally the buildings next to each other. And this was a damage that was identified in a very large earthquake in 1985, a magnitude 8.1. And there are some that have been taking measurements, like these ones, but that happens after 1986. In 86, after that earthquake in 85, Mexico produced a building construction which is very severe and very strong. But the law is not, you cannot apply retroactively the law. So if your construction was before that time, then you are not obliged by the law to follow it. So that's a change. They have to be done because people want to fix their houses. These are damages caused by these small earthquakes that have been happening in Mexico City. Although they are not very large, we could see cracks, and we could see some of them are very large, and people get very concerned and very scared. What could happen if one of these earthquakes could be a little larger? You could see the cracking in the ground. So that has to be a problem. Well, this is the extent of the lake. In this image, it will move later. But you could see that in the lake zone, the blue one, there are 61% of the total of the buildings in Mexico City, and in the hill zone, there is 39% of them. There is roughly about 1 million buildings in Mexico City. So the question is, who's responsible for having these constructions well designed and well maintained and well modified so that the earthquakes will not hit them? This is a map of the buildings that were damaged and collapsed in the earthquake of September 19, 2017. And this is a comparison with the buildings that were damaged in 1985, which were 400 buildings collapsed or were severely damaged. And in 2017, they extend more to the south. And essentially, Mexico City is like a jelly. It's a very soft ground, and there is nothing we could do with the jelly but to eat it. We could not do anything more. And also, then there is another problem: the sinking. Now we are going to have. We just said that Mexico City is like a jelly, and now we are going to say that Mexico City is like a sponge, because the aquifer that is below Mexico City, it is like a sponge. But the problem with the sponge is that we can saturate the sponge with water, but if we put weight on top of the sponge is going to collapse. It's going to reduce its size. And once we lose the original shape, even if we try to pump water into the aquifer, it will not recover. We will need to pump it with a lot of pressure, and it will not going to work because there will be only a few a few wells that we could do to recover the, and these are some examples of what happens with the basement, the deep aquifer, the one that is in blue, it is deeper. They have tested this water. This aquifer is at about more than 1.5 kilometers, and they say that the water is fine. It's been there for many thousands of years. But imagine now to extract water from 500 meters of depth, and also is going to make the city sink, so there is not a remedy. And that causes another problem. The sinking, this is a map of the sinking per year, and this is in meters. The areas that are in red, they are sinking between 35 centimeters and 40 centimeters. That is a huge amount. Something that sinks this building, if we sink it 30 centimeters, and if we do not do it perfectly aligned, if we move a little in one side, we're going to break the building. So it is a serious problem, and it has the problem, the loss of the aquifer capacity breaks the pipes. There is a structural damage for the buildings and the infrastructure, and that's also a problem with the water, the circulation of the water. We were saying that a lot of water, and then we lose about 40% of the water because of the drainage system. We are not going to look into that. This is it's a very complex the geology, but these are evidence of the sinking. Of course, the people that built that colonial building, it was perfectly straight, and this deformation is due to that sinking. We could look at the street there, and also look at the building in the left, and compare the position of the windows, the lower windows, like these ones, they are almost to the sidewalk, and in the other place they were like a meter taller. So that is the rate of the sinking. This is a picture of this particular area where the monument to the revolution is located, and that represents the amount of height that has been sinking since 1960. Now we'll need to add one more of these 200-liter drums. And again, you could see, look at the shape of these buildings. And of course, it is so slow that apparently nothing is happening, but they start just breaking. And we have the loss of the material that is very soft when we have the breakage of the pipes. And another problem that is a severe problem is that where the airport is located is also an area where there is these 30 centimeters of sinking, and they have to calibrate the altimeters of the airplanes. If they do not do that, you could imagine one of these planes, which is very heavy, and if the pilot thinks that he has already hitting the ground and it's 30 centimeters, and then turns off the engines, the plane is going to collapse quite heavily, and it could produce a severe damage to the plane. And they have to be fixing these land strips every other year. They close one. This is the subway. Again, they didn't build it like a Russian mountain. And the drainage, of course, related to the same problem of the existence of an old lake. More than 50% of the water supply is lost. It wasn't 40, it's 50% is lost, and 15% of the city wastewater is treated. So it's a severe problem. There are these gigantic infrastructure that is being built in order to get out all the remnant water from the Mexico City, but it's a huge problem. And you could see all these red lines, which are the main pipes, are going all the way to the north. And it's very interesting because the water from the west, which is the natural drainage of the west, is towards the Pacific. So we take the water from there, move it to Mexico City, use it, make it dirty, move it to the north, and then eventually it goes to the Gulf of Mexico. So it goes from one side to another side, and very, very little is recycled. These are all structures. And you can see that the main drainage is going 250 meters depth in order to get it out of the city. So they are very, very difficult constructions that have to be done in order to remove the water from the place. The capacity of the drainage is 150 cubic meters. It's sometimes with the rain that is exceeded, and there is not the capacity to get it out. And again, these are some of the examples. These are just a few slides that had to deal with the transportation, which is crisscrossed and everything. It looks, to some extent, look towards the mountains, how the road just keep just going towards the mountains and coming down. These are the underground, the subway underground stations, nothing compared to what is here. But the problem to maintain a line that is also in a sinking and moving material is really complicated. These are the hospitals, just to look at the distribution of the things in Mexico. And more or less, this network of buses moves about 8 million people per month, about 290,000 per day, and the subway moves about 3,852,000 people per day. You could see the problems with just when these lines just collapse, because there are these problems due to this the sinking of the city and things like that. We should remember that a comfort zone tells us that in square meters we should have 3 people. We have about like 6 or between 6 and 9 people there. That is way too dangerous to have them, and because they are standing just next to the line. If somebody pushes somebody, they are going to fall on top of the rails. The airport is another problem, which is very important and interesting. In this picture, we could see in about the center, in that red pointer there, that's the Mexico City Airport. It's located 4.5 kilometers from the downtown area, from what we call the Zócalo. And the planes, because of the location of the airport, they have to cross the city, and they fly on top of the city for about 12 minutes. And 12 minutes, it's a lot of time. There used to be about 1,000 landing and takeoffs per day. It has been moved to 800, trying to move them to another airport, but that hasn't been very successful. And the trajectories, these ones are leaving Mexico City, but the other ones are coming from the southwest. And remember the part of what we said about the ashes. There was the proposal of a new airport, the one in the left, that was 60% built, and for political decisions, they stopped the construction, and they continue to do another in Santa Lucia that doesn't have the capacity to take care of the Mexico City. But again, if we look at the last 10 kilometers of the trajectory towards Mexico City's airport, we see that there is 220,000 people, and there are about 87,000 houses in this place. We said that the ash is a real problem. A lot of the planes that are coming from the south of Mexico, they are going to pass this tall volcano Popocatépetl in the east side. And the volcano is emitting some ash, and the day is very clear. The pilot clearly sees the volcano and moves to another route. But if there is a cloudy day, which happens between May and November in the central part of Mexico, the size of the ash is so fine that the plane's radar is not able to decide if it's water vapor or if it's ash. So if the pilot gets into the ash, probably it doesn't get a lot of ash, but he continues to fly. And then in the final approach, the maneuver that they do is they start just taking down the landing gear and the ailerones, the flaps. They start getting down the flaps to slow mechanically, to slow the plane, and they increase the power on the engines. At that point, if they require the power of the engines, the ash has affected the engine, the plane is going to crash. And the problem is, some Mexican pilot may be able to tell where they could find even a smaller park, or where there will be less damage. It's going to lose everyone in the plane, but it's going to do a lot of damage in the ground. And that's a decision that is very complicated, and they have to take it into account. We know that foreign airlines that fly to Mexico City, they have to pay extra to their pilots for landing in Mexico City. But Mexicans, they get paid the same because they're supposed to know what's going on, but it is very important. And the new route, there's a new route, the other one will come from the north, go all the way to the west, and then take the final approach. And now there's a route that comes from the south and then takes to the north, and that passes exactly on top of our university. So now our university could be a place where if they have some damage or some problems, some parts of the university are quite empty. So those are the decisions that they may take. And just a very few things about the socio-organizational phenomena is classified also by the law as a disruptive agent that is generated due to human error or premeditated actions which occur in the context of large concentrations or massive movements of population, such as on this list. Because this is considered an anthropic problem, something caused by the human being, then the law doesn't put money to remedy if something happens. That's very interesting. If it's a natural phenomena like an earthquake, like the sinking, like volcanoes, then there will be money to do the repair of the damage. But in this case, no, they will look for the guilty ones if they could find somebody and somebody could pay for that. So that's a real problem in a large city with 120 million people. It's very often that we see these huge gatherings, for instance, in the downtown area, in the Zócalo. When they feel it, there could be about 200,000 people there. So if something happens, we will have an stampede, and those stampedes are just very, very, very dangerous. And well, that was when the Pumas was champion of the league, and you could see all the people there. So that's one of the main problems, and there are a lot that is trying to protect the population, but it's kind of complicated. And these other type of risks, the chemical, technological, we would like to talk about that because these are generated by the violent action of different substances derived from the molecular nuclear interaction, explosions and fire. And we want to mention that because very recent, on September 10th of this year, there was this huge pipe, this truck carrying about 50,000 liters of liquid gas that they blame the driver that they missed the curve, and then the truck just turned over, and there was this leakage of the gas, and then suddenly an explosion, and the official toll is 31 dead and at least 90 injured. So there has to be regulations, and we would like to end the analysis of this phenomena and to try to say what can we do. And there could still be worse scenarios, the combination of a few of these things. The date and the hour of the occurrence of one of these particular events could be very complicated. For instance, for an earthquake, the worst time will be during the weekday hours when everyone moves to the downtown area where there is a lot of amplification on all buildings, and if it's during those days, then the disaster could be much larger for a particular earthquake. But if we combine the earthquake with a storm, if it's in the rainy season and we have this severe storm, then the rescue operations will be impaled by all these problems. So there's a different type of combinations that could make these things even worse. This is an example. Well, I'm not going to move, but in this particular, mainly at the end of the August, there was this Hurricane Harvey that crossed the peninsula of Yucatan into a Category 4, and then we have Katia with Category 2 that made a stretch path and then entered the country, and then we have one more, Max and Pilar and Libya, all these hurricanes that start interacting in this particular month of September, and we had two very large earthquakes. On September the 7th, we have an 8.2 earthquake in the south part of the country that affected the states of Oaxaca and Chiapas, and then on September the 19th, the very same date of the earthquake of 1985, we have this 7.1 very close to Mexico City that produced a lot of damage. So it looks just like what else could happen, no? So we can see that the nature could be sometimes quite hard. And one of the things that we have to do is to do the risk identification, but more or less we have it, the risk analysis, what is the exposure of humans and infrastructure, and then enters the part of mitigation and planning, not just to do something very quick like the early warning earthquake system in Mexico. It operates when it detects a very large earthquake in the Pacific coast. It will give you at least 50 seconds in advance. There will be the sirens going on in Mexico City, so at least people could try to do something in 50 seconds to get at least out of the building. But again, it is not the real remedy. The best thing will be to take care of those buildings that are not very safe, to modify the structure, to make them more efficient, more hard, so they will resist the earthquake. So we don't have to worry about if we hear the sounding of the sirens going on from an earthquake, we just sit in a chair waiting for the earthquake to happen. That would be the ideal part. And then the risk mitigation plan implementation that will require resource restricted. So for this type of systems, the earthquakes, storms, and volcanoes, there are early warning systems. But again, they are just to tell us that this is going to happen. Essentially, the phenomena had started somehow, was being detected as a storm. And the problem with the storm, although there have been these very severe storms, people don't listen to the way they are broadcasted. We need to be sure that everyone knows about that. And this is a table that tries to evaluate different things of every in each one of the phenomena. For instance, if the phenomena, when it hits, is costly, what is the impact in size, how many people, if it could be preventable, if there is a health impact, if there is a social impact. The social impact will be interesting to know that, for instance, the earthquakes, people continue to be scared for months, for years. And other situations, like when there is flooding, they will be concerned for about a few weeks. So the impact is not very severe. Or even the explosion, the gas explosion, the example that we took for the chemical technological, people tend to forget about 1 month. 1 month later, the news doesn't even show whatever happened to that situation. So that is the impact. And the temporality is where they could occur. The ones related to the water problems, the hydrometeorological, are related from May to November. The pollution from November to May, because there is no rain there. The volcanoes from May to November, in particular for the Popocatépetl, because the wind will be coming from the Gulf towards moving the ash from the volcano towards Mexico City in this time of the year. Earthquakes, it could happen any day. The sinking also, the drainage will be related to the rainy season, the transportation, the airports, and the chemical, technological, and the social organizational, they could happen anyway. When we look at these different situations, we see that the one that has probably the most is earthquake. The earthquake, a large earthquake, is the cost is really large. The impact, very curiously, is not very large. It's very concentrated in some parts of Mexico City, or some parts like in Chiapas and Oaxaca, but it's not very large. But it's important. The question is if we could prevent what will happen. Yes and no. If we decide not to do anything, then it will happen. If we decide to do something, like to repair, reinforce, things will be much better. It will have an impact in the health, and the social impact. It also will last for years. People will be thinking about when is going to be the last earthquake, and when they hear the early warning system, they get very scared and concerned and complain. Actually, some of them, they say that they should change the sound of the seismic alert system, and say, well, now that is the purpose, that when you hear it, you really react. So with this in mind, if we look at who has responsibilities, of course, the government has responsibility, but also we that are in higher education institutions. No? A lot of this research is done in our institutions, and also the people. The people have the obligation to know about what kind of phenomena could affect them. And what we need to give them high priority, because they say, no, there's not been an earthquake, we don't worry. Or now it's raining a lot, we don't worry about droughts. The money is an issue, now there is not a lot of money. And another problem that is very important is the continuity of actions and collaboration. And the problem is that the government, the local government, the very local one, the municipalities, they change every 3 years. At the state level, they change every 6 years, and at the federal level, they change 6 years. So when somebody gets experience, they change. The new government arrives, and they get rid of all the people, and that experience is lost. Something that doesn't happen with the universities. At least we prevail more than 3 or 6 years. We hope so, we get more, but we don't tend to get involved. We assume that our purpose is just to do research, and that the decision making it's something that has to be done by the government. So we need to get more involved, collaborate more in order to do some type of mitigation. An important event on natural or anthropic will happen. The answer is yes. We have found selection, and will it be a disaster? And that depends on us. If we do nothing, it will be a disaster. If we do something, at least to make people aware, something will change. And with this, I would like to end the talk. Thank you very much for your attention.
Thank you very much, Carlos. We have some questions here from the public. Sergio Godínez told us, you talk about several types of hazard happening at the same time. From what you have seen, which combination worries you the most?
I think my experience with that slide of the 5 hydrometeorological events, and then having 2 very important earthquakes was very, very complicated, because fortunately Mexico had an insurance for large earthquakes. That's a very interesting insurance. The insurance was, if it's a very large earthquake, there were cells in the whole country, regions defined. If an earthquake of such a magnitude will happen, will pay, or a hurricane category 5, and they were measuring the importance of the hurricane based on the pressure. And when the earthquake happened in September the 7th, 2017, then the pay was $100 million, and that was almost ready, very, very, very quickly it was available. That helped quite a lot to start just mitigating the impact, and help right away the people that were suffering in the states of Oaxaca and Chiapas. So everything was just going under control, although there were still several of these storms. And then on September 19, there was this earthquake that affected regions in Puebla and Morelos and Mexico City. And it's very interesting, when something happens to Mexico City, we from Mexico City get crazy, and there was just no money. The money was spent in the other event, and everyone was tired because the situation was complicated, and people keep asking, not only we have another earthquake within a few days, but we have it the same day, the 19th. People start saying we should get out of the calendar September the 19th. And up to this date, when September 19 gets closer, people remember. And I think to that, we mean that in this August and September, we had these huge storms in Mexico City. If we have one of these storms, when there are all these situations, complicated situations, rescuing people and doing these things, that would be a terrible scenario.
Thank you, Carlos. Dark asks this question. Is there a way to develop quantitative metrics to assess and project infrastructure damage from unpredictable natural hazard? How could these metrics guide long-term urban planning?
I think we have one very powerful tool which is available to everyone is I used a few examples, the National Risk Atlas. You could enter without having a password or whatever, and it gives you could select an area and give you the information of the exposure of the people that live there divided by old and young people and men and women. And it has the information of a lot. You could look at the schools that are there. It could give you a table, an Excel table to do a lot of work. So the thing that we need to decide is what is the impact, what is the phenomena, and what is going to, this phenomena, how is going to impact. It's very different if we have a heavy rain, if we had a flood, or if we have a landslide, for instance, or if we have an earthquake, and if we are talking about the school. The damage and the impact is going to be different. So that's what I keep pushing, that maybe the universities, because we talk even about the social aspects, the psychology behind all these earthquakes, we could get together and work in a plan that devises what they are asking. We should be giving numbers to this situation.
Okay, and what related with this, what is the biggest challenge in communicating risks to the public, especially in a city with such as complex hazard profile?
It is very complicated. It's curious because now we have a device, the cellular phone, the mobile phone, that could help us a lot, but we decide to be using it for other purposes, and also the campaigns to transfer this information, they have to be specifically decided for what group of people they should be going. If you are going to talk to young people that have less than 20 years, it has to be something different, something very attractive, something that they also could play. Because if it's something boring, if I start just talking about earthquakes, in 5 seconds they are going to move to another message. So we need to be doing it very specific to try to get across, and also just to use the information in radios. People tend to use a lot now the radios. The television now is so sparse that it's complicated, but radios and messages through the mobile devices probably will be a best way to start.
Well, Carlos, thank you very much for this
Thank
wonderful presentation, and let's
All the time I'm thinking about this very big old building that is supposed to be safe in Reforma, for example.
Yes.
Supposed to be safe because they have high technology for
Yes.
the answer. But I'm saying there's a very big earthquake. So I don't think that even though they have the most recently technology, I doubt it because I am not knowing much about that. But I think that the school government,
It probably structurally will be safe structurally, because they have to, for a tall building more than 20 stories tall, they have to have a special system to put the pilotes and yes, but other things start just getting in the way. For instance, these buildings are completely sealed. They don't have windows. They have air conditioning systems. So if something happens, because now we could see we have a lot of cables, and we start a fire, and the fire, because of the material, starts spreading out. We just saw this incredible Hong Kong fire that consume like 5 buildings. It's just horrible because they start just going so fast and so quick. And the firefighters, there's no way they're going to be able to do that. So the secondary problems, because of the strong motion, the structure will be fine, but if we have a fire, if some of the doors get jammed because of the motion of the building, and also they have these glass curtains now, and the glass has to be bulletproof, which is about 1 centimeter thick, and they have these very huge sections of glass, which are just trapped by special devices. They are called spiders. And most of them are developed in Italy. And I keep asking them, I say, the earthquakes in Italy are not that strong as the ones in Mexico. So if you have to go through the glass and then just hold it just with a few points, 4 points. So if the glass breaks and it's coming down from 30 stories high, this is a flying guillotine. I mean, if somebody gets hit by that, that's a disaster. So these consequences are the ones that they take not so seriously. They have to be doing probably drills every 2 or 3 months, and severe drills. Let's get out of the building. How easy is for a person that is in the floor 30 to get out? For instance, we like to have special shoes. Women use shoes, very nice shoes, but if they are high-heeled shoes, they are not going to be able to walk down. They should have tennis shoes to get ready in them, and they just go downstairs very quickly. If there are some older people that cannot move that quickly, all those things, they have to be taken more seriously. And what happens in Mexico is that we have a national drill, September 19, and that's it. So if something goes wrong, next year we don't remember what happened. We need to do them often, and on those buildings, I will do them very often. Yeah.
Wow.
Thank you.
Thank you very much, Carlos. Thank you for your wonderful presentation.
Antonio.
And to the public, we will be here next year. Thank you very much.
Thank you. Gracias, Antonio.
Gracias a ti.